Hello friends, welcome back. Here I'm going to solve one more question from GATE 2025 question paper of Electronics and Communications Engineering. Here we can see that there is a differential amplifier has been given in this question. Here this differential amplifier consists of two MOSFET M1 and M2 and they have a transconductance GM of 5 millisiemens and their input signals V1 and V2 are given as V1 is equals to 2.5 plus 0.01 sine omega t and V2 as 2.5 minus 0.01 sine omega t. So now we need to find the output signal V3 in volts. Here if we see there is the V3 output signal consists of two main parts. So we can write here that V3 output signal consists of V3 DC part and V3 AC part. So we need to calculate both the parts to get our answer. Now if we can see there is a current source at bottom of 2 milliampere. This 2 milliampere is divided between both the differential stage circuit as equally as 1 milliampere. So this goes as 1 milliampere and this will be 1 milliampere. So and this same 1 milliampere is flowing through this 1 kilo ohm resistor also. So this will be come out as, if we see the circuit to calculate the V3 DC part, we can apply the current voltage relationship here. So it will come as VDD minus V3 DC part. So will be equals to 1 kilo ohm into 1 milliampere. So VDD is given as 5 volts. So this will come V3 DC part as 5 minus 1 volt is equals to 4 volts. So if we can see from the options, we can say that either C or D will be the answer. So let's now calculate the V3 AC part. So to calculate the V3 AC part, we need to remember that there is a standard formula for differential stage amplifier. Like here, there is a standard formula to calculate the transconduction of a differential stage amplifier. This is like here the output signal V V3 that, so V naught is equals to half in brackets minus GM RD. RD is the resistor at drain side. So with this, if we put V naught as V3 AC part, so we can say that V3 AC part will be there is one more thing, and V naught upon the V input. So again we need to find V3 AC part upon, here the input is to the AC part is 0.1, so 0.1 minus of minus 0.1, so it will be 0.1 minus of minus 0.1, so this will be equals to half into GM is given as 5 millisiemens, so 5 Siemens, and where drain resistor is 1 kilo ohm, so we need to write 1 kilo ohm, so this will come out like minus 5, so this will be V3 AC upon 0.02 equals to 1 by 2 5 minus 5, so this will come out minus 2.5, and if we calculate completely, it will come as V3 AC as minus of 0.05. So so from here we found V3 DC as 4 and V3 V3 DC as 4 volt and V3 AC as minus 0.05 volt. So the total answer would be V3 equals to V3 DC plus V3 AC, which will be coming out finally as 4 volt minus 0.05 sine omega t. This is the answer here, option D.